Hello, students, and welcome to Fantastic Chemistry. I'm your teacher, Mr. Flynn. Today, we're going to be learning about radioactive processes. And there are three major types of fast-moving subatomic radiation that I want you to learn about, because the other type of radiation that we've learned about is electromagnetic radiation, and that's just pure energy. What we're talking about in this video is actual particles that are moving near 5% at the speed of light. Okay, these are fast-moving particles, subatomic particles, to be more clear, and they're being ejected from the nucleuses or nuclei of atoms. Okay. Now, if you come down here, there's a definition I'd like you to write down. Okay. Alpha decay, an unstable nucleus emits an alpha particle. Okay. This is kind of a not very clear definition, because what's an alpha particle? Well, I want you to add to this definition as we go. Okay. Electron capture. You are not going to be required to learn about that in this class. So this bottom section, you just pretend it's not there. Okay. So we're just going to talk about these top three up here. All right. So let's get started. So what is an alpha particle? So if we look here, we've got a uranium nucleus, and it's got 92 protons and 146 neutrons. And the reason it's uranium is because of this atomic number. Okay, the atomic mass is much larger at 238. That's because there's so many protons that we need more neutrons to help stabilize those 92 protons. Okay. And there's other isotopes of uranium that are even more radioactive, but this is actually the stable version of uranium. And because it's so large, it will emit these alpha particles, which is essentially a helium atom with a 2+ charge. It doesn't have electrons, so it's just a helium atom. Okay. And uranium is going to lose 2 protons, so it's going to turn into an entirely new atom, and it's now going to turn into thorium. Okay. And if you look here, it's now 234, so it means it lost 4 of its 4 atomic units there for its mass, because it has 2 protons and 2 neutrons. Okay, so when we're doing alpha decay problems, this is the equation. You're going to learn to solve these equations. So you're going to basically minus 2 from the atomic number and then 4 from the atomic mass. And we're going to show that we've lost a helium atom. Okay, and then just to give you perspective, these particles are traveling very fast. Okay, they travel about 5% of the speed of light. Okay, electromagnetic radiation travels in a vacuum at the speed of light. Okay, but these alpha particles, even though it's 5% of the speed of light, it's still traveling very fast. Okay, and they can penetrate through different subsurfaces. Okay, all right, now let's talk about beta minus and beta plus. Okay, this is where it gets a little bit confusing for a lot of students. Okay, and if we look at this first problem, let's just make an observation of what's happening. Okay, we go from 6 protons to 7 protons, and we go from 8 neutrons to 7 neutrons. So it looks like a neutron is turning into a proton. Can we see that just based on this observation? All right. So as this happens, what's going on is a carbon is having one of its neutrons turning into a proton. So it's actually changing the atom. But if you notice, the atomic mass is staying the same, and it's letting off an electron. Okay. All right. So I don't need you to necessarily know the what antineutrinos are. Okay. We're not going to discuss those in this class, so don't worry about this. But all I want you to know about is that beta minus decay is when a neutron changes into a proton and releases an electron. Okay. In a beta plus decay, we have the opposite occurring. We have a proton turning into a neutron, and it's releasing something called a positron, which is a positive electron. Okay, it's feeling a little strange. You're like, why is everything interchanging with each other and going through these processes? And the reason these processes are occurring is because of the weak nuclear force. We talked about that in a previous video. If you're feeling like you don't understand that well, go back and watch that video, because that's what's actually causing all these reactions to occur. So if we look at this carbon, it's going from a 6 to a 5. It's losing a proton, but its mass is staying the same because protons and neutrons are the same. And it's gaining a neutron instead of a proton, and it's letting off a positive electron. Okay, so I'm going to write these off to the side to give you some perspective. Okay, all right, so in an alpha decay, okay, it is essentially the ejection of a helium atom with a 2+ charge, and that's being ejected from the nucleus. Okay, we have beta minus, okay, or we can write it as a negative, okay, and that's going to be a neutron turning into a proton, and it's going to be releasing an electron. So the electron is going to be emitted. And then we've got a beta plus, we can write it as a plus sign, is a proton turning into a neutron, and it's releasing an electron, but it's positive. So we're going to call that a positron. And that positron is going to be emitted. Okay, so we have alpha particles, beta minus, beta positive. We also call these electrons and positrons. Okay, so these are the three types of fast-moving subatomic particle decays that I want you to know for this class. Okay, so make sure you get this definition, add to it. Okay, put this in your notes. All right, you're going to need it. Okay, all right, thanks again. Thanks for watching.